Okay, so today you and I need to talk about some important functions and talk about their domain and range. So you should know how to graph any line at this point, and a line's domain and range is of course all real numbers because I can input any x value and get any y value. The domain and range for a quadratic, this is where we start to have to think about domain and range. Now domain, we can substitute any x values. However, with the range of this function only shows up here. Okay? So that means that the range has to be all of these values. So you need to say something like y is greater than or equal to 0. Domain and range for a cubic function. Well, all of a sudden, again, you can go as far left and right as you want, but now you can also go as far down and as far up as you want. So this is all reals. Domain for a rational function 1 over x. Well, it looks like to me that the x value cannot be 0, so we'll just say x cannot be 0. And then for the range, it looks like the range shows up almost everywhere except for right here at y equals 0. There's no value right there. Okay? So we're just going to say that y cannot equal 0. The domain and range for 1 over x squared. 1 over x squared is just almost like 1 over x, but they're both on top, right? And that might make sense because x squared is always going to be a positive number. So when you look at the domain, you're thinking x cannot be that middle number. It cannot be here because there's a vertical asymptote. Remember, 0 in the denominator is not allowed. And how about the y value? Well, the y values, they're greater than 0, but they'll never be 0. So we can just say greater than 0. And here's the bottle rocket, y equals square root x. The domain appears to be everything that is greater than or equal to 0. So that means that anything on the inside of this needs to be greater than or equal to 0. And the range is also going to be greater than or equal to 0 because it's all of these values. This thing keeps on going up. Oh man, x to the 2/3. We don't see that too often, right? But looks like the domain is going to be all reals and the range is going to be greater than or equal to 0. And e to the ax. E to the ax. Let's pause on that one. Okay, so this one says e to the ax. So if a value is positive, this is going to be an exponential growth problem. If it's negative, e to the negative e to some kind of negative power in front of that x, it's going to be an exponential decay problem. Now, why does that happen? Well, let's just look at y equals e to the negative x. That's going to be the same thing as 1 over e to the x. And that looks like to me that that's always going to get smaller and smaller by division. So when you divide and divide and divide and divide and divide, that quantity just keeps getting lower and lower. Okay, so the domain for each of these, it looks like to me, is all reals. I can substitute anything in, and I'm not going to get an error in the calculator. As for the range, it's got to be greater than 0. Now think about that. If you keep on dividing, are you ever going to reach 0? No. Not theoretically anyways, right? Realistically, you might get close enough to say, okay, it's 0, but not theoretically. All right, so now when we look at the natural log of x, we notice that, well, you know what? It kind of almost looks like, visually, it looks like we're touching 0. But we'll never actually touch 0. And if you want to prove that to yourself, you can go to the TI-84 calculator. And when you go to that calculator, you can type in the natural log of x and type trace and type 0, and you will get nothing there. Okay, so it's infinitely close right here, but x is greater than 0. And then the range, there's no limit to the range on this one. That's all reals. All right. Okay, guys, that is a list of important functions to know for calculus. And I hope you get to a point to where domain and range is pretty comfortable for you. And I hope you enjoyed the video. Take care.